Binary search is a smart way to look for a value inside a sorted array. Instead of checking every single element, we keep dividing the array in half to quickly narrow down the search range. Here's how the algorithm works. We set a variable left at the start of the array and right at the end, then calculate mid using the formula mid equals left plus right minus left divided by 2. Next, we compare the number in the middle with the value we're searching for. If the two values are equal, we've found the target and return mid. If the number in the middle is greater than the value we're searching for, that means the target is in the left half, so we update right equals mid minus 1. On the other hand, if the number in the middle is smaller than the value we're searching for, the target must be in the right half, so we update left equals mid plus 1. Each comparison removes half of the unnecessary data, which makes the algorithm extremely fast. It only takes around 10 steps to search through 1,000 elements. We keep repeating this process until we find the value, or until left becomes greater than right, meaning the value isn't in the array. In short, binary search follows 3 main steps. Split the array in half, compare the middle element, and eliminate the half that doesn't contain the target. For example, imagine you have a sorted array with numbers 1, 3, 5, 7, 9, 11, 13, and 15, and you want to find the number 9. First, set left at the beginning and right at the end of the array. Then calculate mid using left plus right divided by 2. The number in the middle is 7. Compare 7 with 9. Since 7 is smaller, we discard the left half and keep only the right. Now the array left to search is 9, 11, 13, and 15. Calculate mid again, it's 11. Compare 11 with 9. Since 11 is greater, we drop the right half and keep only the left. Now only 9 remains. Compare, and there it is, we've found the target. That's how binary search works. Divide the array, compare the middle value, remove the unnecessary half, and repeat until you find what you're looking for. Fast, simple, and incredibly efficient.